When Tom Sanlandra interviewed Joseph Prusa at TCT 2017, Joseph commented, "I wonder why nobody has cloned the Mark II 1-to-1. Well, Joseph, now they have. Before we get started, let's make a deal. YouTube hates it when I send people to other websites. They want everyone here watching videos. So to counteract that problem on this video, I would really appreciate it if you like and subscribe, watch to the end of the video, leave a comment if you wish to, and then, at your leisure, take a look at the links in the description. You'll want to subscribe anyway, because part 2 is going to be an epic live stream describing a lot more details than I can provide you in a single video. So how does one go about actually replicating a printer? Well, firstly, you need a BOM, a bill of materials, a list of all the items needed to build the printer. Then, of course, you need to purchase them, and finally, you need a method of instructions to put them all together. And, of course, you throw some firmware in there somewhere too. My first stop for a BOM was Prusa Research. Unfortunately, they didn't have one. Plan B was to go through the assembly manual step by step and take a list of all the parts needed at every stage. That way, I could then collate all of those into a functional bill of materials. It was a long and tedious process, but one that turned out to be fairly valuable anyway. It's worth noting though that there are some big differences between having a bill of materials and actually having all the information needed to be able to purchase the right parts. For example, some parts such as the E3D hot end and the power supply come pre-assembled. So there's some sort of reverse engineering in there somewhere to just determine what parts are needed in order to build up those assemblies. And no, the hot end is not a standard E3D V6. Also, there tends to be some missing specifications. So for example, the Extruder Springs. How thick is the wire? What is the internal diameter of the spring? What's the spring rate of the spring? What's the resting length of the spring? These are all details that I just didn't have and would need to find. Other items have sufficient detail, such as the U-bolts for the bed, but they're very difficult to find online or in a shop, and thus extremely difficult to buy. So with the BOM sorted, the next thing I needed to do was find out which of these parts were going to be hard to buy. I basically made an educated guess on what I thought might be difficult to source, and then I went and looked at those parts first, tried to find the more difficult parts, because if I couldn't find one of those, then that might be a bit of a stumbling block for the entire project. Fast forwarding through most of my hard work, let's skip to what you actually need to buy. I'm not going to go through every single part in this video. I will though be doing a live stream. In that live stream we can go through every single part of the bill of materials, and that will give you an opportunity to ask questions too. For now though, let's take a look at the parts where I diverged from the original design in ascending order according to the deviation magnitude. Of course, how different they are from the original. Firstly, the Extruder Springs. So I didn't find any information really regarding any of the detailed specifications like I mentioned earlier. So I settled on a Mark 8 extruder spring. It's a little bit stiff and a little bit big, but it does work as long as you just have one. Secondly, the connectors on the E3D thermistor are basically in the way on this design. The original Prusa cut them off and soldered them to the wires for the thermistor that go back to the control board. I didn't want to do this because I didn't want to end up with a brittle failure, so instead I kept the connector and just routed it slightly differently around the carriage. Thirdly, the original lead nuts are significantly different to the common brass nuts that you probably already own, and I couldn't find where Prusa bought theirs from. So I guessed the internal thread geometry, I knew the external geometry, and I made a model and sent them to be graphite SLS printed. While the tolerances on those are a little tight, they do still work pretty well. Fourth was the LCD display. So standard displays like this one have a slightly different potentiometer to the ones used on the original Prusa. It's quite a bit thicker, and so the brackets on the back side don't slide across and sit in place like they're meant to. So I basically cheated and didn't actually attach that second bracket. The screen is a little bit loose, but most of the forces are pressed down onto the screen, so it still holds it pretty well. If you want to identify that exact potentiometer they used so it's nice and low profile, then you can resolder it and put the proper one on, but for me that was more effort than was really needed to actually obtain the correct functionality. Fifth was the main frame, and you can see that mine is quite significantly different to the original Prusa. But really it's got all the same geometry. I took the DXF file that they provide, loaded it into CAD, did some higgery-jiggery, flipped the holes, so I got them both sides, added some extra geometry that I'm going to use on a separate project, and other than that, it's pretty much the same. So while I wouldn't recommend you try and get exactly this one, you can get Prusa frames that are basically identical to the original Prusa for about £50, and that's probably your best bet. Sixth, the high current power wires that I used were 14 gauge silicon with sort of thin multi-strands inside. So it's nice and flexible, but it is a little bit thicker, in fact quite a lot thicker, than what was used on the original. I chose these because I didn't know what the originals were and I wanted to have a sort of a safe bet. And these were pretty safe because they're nice and thick. If you know better, then you can probably get away with something a little bit thinner. The only information I could obtain about the stepper motors was their body length and of course that they were a NEMA 17. So I couldn't find the exact length needed, so I just went for something very slightly longer. It turns out that these were cheaper and they also allow the Z motor wires to fit a little bit better. Eighth was the integrated lead screws. Obviously these join to the stepper motors, so different stepper motors, different lead screws. But the reason I chose not to have integrated screws is that getting them from a low-cost source, they tend to arrive a bit bent. So in order to overcome that, I decided to go with a coupler with a separate lead screw. I wouldn't recommend a printed one, but you can get good jaw couplers or rigid couplers which should do pretty much the exact job that you need them to. By far the hardest component to get details on was the power supply. While I knew it was a 12 volt and 240 or 250 watt unit, I couldn't get the external geometry, I didn't know the model number or anything, so I couldn't find the exact size. So unfortunately this was probably the biggest downside of the project. Although I managed to get the right capacity power supply, and it is still fanless, I did have to create a completely custom box to fit it in, because mine's a completely different geometry to the one that Prusa uses. So it's not the best in terms of 100% replica, but it does the job perfectly well. Of course, as a result of all these variations, I did have to deviate slightly in the build process. But if you do want to build this, the genuine, actual Mark II Prusa manual will still serve you just fine. So what is the print quality like? Well, this is the very first one off the printer, a 120% scaled benchie. I noticed two problems. First is this scaly sort of effect. While it doesn't make too much difference to the print geometrically, for aesthetic pieces, it does sort of degrade that appearance quite significantly. The second is under extrusion. I'm not too sure why it's so under extruded. My testing after this suggests it's about 20% under. However, that's not a great concern because I didn't skip any steps or have any significant problems like that, so I just bumped the extruder multiplier. In terms of price, this project cost me a little bit more than an original Mark IIs. But that's mainly because of, one, the failures I had to make. I didn't have to make, but the failures I made during the process, which resulted in me buying parts twice. And secondly, the custom frame. Buying custom-made water jet components is not cheap and, well, the frame that I bought was particularly expensive. When you take a look at the BOM, you'll notice that you can actually build this project for around £400, which I think is pretty good. That's excluding printed parts. But remember, this is just for the printer. You don't get any customer support. Anything you break, you will have to pay for to replace. And any mistakes you make, you'll have to buy something again. So while you can do it for less, that doesn't guarantee that you'll have a working printer for that price because of those problems. So should you build one? Well, the main reason to do this would be for fun. And there are of course some small financial savings too, potentially. But if you want an easy build with great technical and customer support, buy the original because the clone will not be straightforward. There's almost certainly going to be some niggly problem that you have just because that's the nature of doing things yourself. And finishing off on the ultimate question, why did nobody else try to clone one? Well, if we're talking about large companies trying to clone and sell them, then I think the reason is because the Mark IIs was a representative of a high quality printer. But that, in turn, resulted in a higher cost. I wouldn't be surprised if some Chinese companies did attempt to clone it. They did have their own working version, but they couldn't get the price down to below what they were already selling. And in the last few years, the trend has been to reduce cost further and further and further and further. So while they did have potentially a clone that they could have sold, it just wouldn't have been at a price that they thought was worthwhile and therefore didn't bother selling it. Maybe I'm wrong, but that's my initial thoughts. So that's it for part one of my Mark IIs replica build. You'll want to subscribe for part 2 because that will be a lengthy live stream where I'll pass on lots of details and you'll have a chance to answer questions too. But for now, thank you very much for watching and I'll see you in the next one.